Today we're going to discuss once again our trig functions, sine, cosine, tangent, cosecant, secant, and cotangent, and how those relate to angles in both degrees and radian measures in our unit circle. So before we do that, we need to talk some terminology. First of all, we need to talk about quadrantal angles. And whenever you hear that expression, it talks about angles whose terminal ray lies on a axis, if you will. So here's 0 degrees lying on the positive x-axis, 90 degrees positive y-axis, 180 degrees negative x-axis, and 270 degrees negative y-axis. Reference angles are a big deal, and they're defined as the following. Given a non-quadrantal angle, so it can't be on an axis, a reference angle is defined as the angle distance, all right, and that's kind of my terminology, of the terminal ray to the nearest horizontal axis. So we're going to find some reference angles moving forward here. Let's take 200 degrees. Now I know if this is 180, 200 degrees, and I like putting everything on a circle just because it gives me more of an indication of some of my relative horizontal and vertical distances. So here's roughly 200 degrees, and the reference angle is defined as the distance in degrees or radians to the nearest x-axis. Well, I know that the nearest x-axis is right here, and if this is 200 degrees and this is 180 degrees, then this angle must be 20 degrees. So my reference is 20 degrees. And what's unique about that is it states that if I look at my circle, I know in a circle, since it's symmetric about an x and a y axis, that this horizontal here and vertical here is the same horizontal and vertical as what it would be over here. It's just it's in a different quadrant, so the values of x and y are different. For instance, I know this has some x over and y up, and this has that same x over and y up, except they're both negative since they're in the third quadrant. And that's really important because, once again, we're symmetric over the axes since it's a circle. If I'm at 92 degrees, that's right around here, and most people want to say my reference angle is 2 degrees, but that wouldn't be correct because that's the nearest y-axis. I need to go to my nearest x-axis, which is right here, and figure out what that theta value is. And from 92 degrees to 180 degrees, we just take that difference, and that's 88 degrees is my reference angle. And once again, what that states is it states that this horizontal and this vertical is equivalent to the horizontal and vertical here. So if this is xy, those values will be the same as these values here, except the x value will be negative. So in absolute value, they're all the same distances. Let's keep going so we can get a good handle on this, because this is really important. 345 degrees, right around here, and that goes all the way around. And what that states is this is some horizontal and vertical distance away. I want to know how far away from this x-axis am I? Well, that's a reference of 15 degrees, which states that, once again, the xy here and the xy here are the same, except for the fact that since we're in the fourth quadrant, this y value is negative. 781, this is a little different because now I've gone around more than one time. In fact, 360 times 2 is equal to 720, so I've gone 2 times around. 1, 2, and that puts me at 720, but I've got to be 781, which puts me, I don't know, somewhere around here-ish. Alright, and that angle here is how far away from this positive x-axis. Well, we knew this is 720. It's also 360 because they're coterminal, also 0, right, etc., etc., etc. So 780 minus 720 gets me 61 degrees, and our reference is 61. Since they're in the same quadrant and coterminal, this x and y is the same, exactly the same in both cases. So with negative 138, I'm rotating not quite halfway around a circle, but I'm rotating in that clockwise fashion, putting me somewhere here. My reference angle is this angle here, which means how far am I away from this x-axis, and I can take the difference and end up with 42 degrees. Now, even though I'm rotating in a negative fashion, the reference angle is always defined as a positive angle measure, only because it's a distance, and distances are measured in terms of absolute value. So my reference is 42 degrees, which means this angle's relative x and y is equivalent to 42 degrees x and y, except since I'm in the third quadrant, both of these x's and y's would be negative. And I'm going back again and again to that concept because we're going to need that very soon. So let's do some reference angles for radian values. If I'm at 2 pi over 3, remember 1 pi over 3 is 60 degrees, 2 pi over 3 is 120 degrees, which is somewhere around here. So what I want to know is if 3 pi over 3 is pi, how far am I in terms of radian values from 2 pi over 3 to 3 pi over 3? Well, it's pretty easy to see. That's just pi over 3 is our reference. Let's go down to another positive. The way I like doing these is if I have an improper fraction like so, I change it into a mixed number. This is 5 and 3/5 pi. So if this is 0 and this is pi, and every time I go halfway around a circle I'm at another pi, so this is 0, 1 pi, 2 pi, 3 pi, 4 pi, these are all coterminal angles, 5 pi, and now I have to go 3/5 pi more. Now 3/5 is bigger than a half, and here's that half, so this is 5.5 pi, so I'm a little bit more here. So this is 5 and 3/5 pi, which means I need to know how far I need to go to get to this right here. And to get to 6 pi, I have to go how much more to get to a whole nother 1? Well, if this is 3/5, 4/5, 5/5 put me at another pi, right? So I'm really reference of 2/5 pi away. Negative 13 over 9, again, improper fraction. I would change that to negative 1 and 4/9 pi. So here I am at negative 1 pi, and here would be 2 pi. Again, 4/9 is a little bit less than a half, so I'm right around here. So this is negative 1 and 4/9 pi, and I need to go right to here. Well, I know if this is 1 pi and this is 4 more ninths pi, that must be my reference angle. So my reference is 4 pi over 9. So there's our discussion of reference angles. Now, what I've done is I've outlined what we already know. Here's our unit circle. We've got a radius of 1. Here are our degree measures in terms of 30s, 60s, and 90s. And let's throw in our 45 degrees. And we have all of our radian measures, which are equivalent to our degree measures. I've got over here a special right triangle, 30, 60, 90, and a 45, 45 right triangle. And I know that the short side is half the hypotenuse. So I know that this is 1/2, and the long side is equal to the short side √3, so that's √3 over 2. Likewise, I know that my side √2 is equal to my hypotenuse. I know my hypotenuse is 1. So if I divide by √2, I get my side. Side, in this case, equals 1 over √2, or √2 over 2. So here's where this is going to come in. So what I'm going to do next is, using this information, I'm going to take and find x and y values for each of these angles and where they lie on this circle. And we'll do it on a cleaner piece of paper. So I know if this is a unit circle where my radius is 1, I know this has a point of 1 and 0. Likewise, since this is straight up and down, this is 0 and 1. This is -1 and 0. This is 0 and -1. Common sense. Straight lines out in all directions. Now, 30, 60, 90 right triangle, we just found that the short side, in other words, if I find my x value is half the hypotenuse, my y value is the short side because this is a 30-degree angle, so half the hypotenuse, I know the hypotenuse is 1, that's a half. And then the long side, which is opposite the 60-degree angle, remember 30, 60, 90, is the short side times √3. So this has got to be √3 over 2. We'll put our 45-degree angle in right here, which is equal to pi over 4. And I know from our last example, we know that the side is equal to √2 over 2. And we know that since this is a 45-degree angle, what I have is a, once again, a right triangle that's isosceles because 45 and 45. My x's and the y's are the same, so this is √2 over 2, and this is √2 over 2. And then when I go to this 60-degree angle, this also creates a right triangle where this is 30, 60 down here, and 90. Again, my radius is 1. My short side, which is my x value, is half the hypotenuse, so this is a half. And the long side equals the short side √3, so that's √3 over 2. So notice what I've got here. I've got x and y values for each of these points at the end of these radii of length 1 on our unit circle. Now, because I know that circles are symmetric around both the x and the y axis, if I were to flip this point over my y-axis, it would land exactly on this point right here. This is kind of what I was talking about with our reference angles. So I know that this is the same x and y distance away, however it's in the second quadrant, so my x value is negative. Likewise, at 135 or 3 pi over 4, I have root 2 over 2 and root 2 over 2. In this case, my x is negative. And if I once again flip over here, same x and y, but my x is negative since I'm in the second quadrant. Now I can fold all this over the x-axis, and each of these points will fold on to the points down in the third and fourth quadrant. So let's go ahead and do this. When I flip this point over, it lands to here, but since I'm in the fourth quadrant, both x's and y's are negative. And likewise at 225, which is 5 pi over 4, I end up with negative root 2 over 2 and negative root 2 over 2. And then flip this point over, that's negative a half and negative root 3 over 2. Flipping over here, I have root 3 over 2 for the x. But since I'm in the fourth quadrant, my y is a negative half. I'm at 315, or 7 pi over 4. That's that's positive root 2 over 2 and negative root 2 over 2. And finally, I have 1/2 and negative root 3 over 2. Again, this was a very intuitive approach, but we found all x and y values for 30, 45, and 60 degree multiples around a circle. These values are really important. I've cleaned it up for you a little right here. And again, it's going to be very important that you get to know these as soon as you possibly can. So let's go back to this whole concept of being in a circle, creating an angle, which also creates some vertical and horizontal distance in a right triangle. Now in a regular circle, if we wanted to find the cosine of this angle, we'd say that the cosine is equal to the adjacent, or your x value, over the hypotenuse, which is your radius, and the sine would equal the y value over the hypotenuse, or the radius. But since this is a unit circle, where r is equal to 1, we can now say the cosine is equal to x over 1, or x, and the sine is equal to y over 1, or y. So then we can say that this xy is equivalent to the cosine of theta and the sine of theta. So therefore we also know not only the x and y values of these 30, 60, and 45 degree multiples around a unit circle, but we know the sine and cosine values for the 30, 60, and 45 degree multiples around a circle. And for any circle, tangent's always equal to y over x, because it just rules out the hypotenuse completely. So what we're going to do now is we're going to find some trigonometric values for specific points on a unit circle. And you've got to answer 3 questions. 1, where are you? 2, what are your points? And 3, which one do you need? So if I'm looking at the cosine of negative 90, I first have to know where I am. Negative 90 degrees puts me right here. Rotating clockwise, quadrantal angle. And at this point, if I'm on a unit circle, I know my x and y values are 0 and negative 1. And the cosine is asking for my x value. So I want to know my x value at that point. My x value is 0, and that is the cosine of negative 90 degrees. For 210, I need to know where I am. 210 puts me right around here. I like thinking about my reference angle, which is 30 degrees away. Alright, and at that point, I have values of negative root 3 over 2 and negative half. And I'm talking about the sine, so I need my y. Therefore, sine of 210 is negative 1/2. Secant of 180, well, once again, where am I? I'm at 180 degrees, which is over here. My x and y values are negative 1 and 0, and secant is 1 over the x value. So if I take 1 over my x value of negative 1, I end up with negative 1. Tangent of 3 pi over 2. Where is 3 pi over 2? Right here. My x and y values are 0 and negative 1. Tangents y over x. And in this case, my y value is negative 1 over x is 0, which means I get a division of 0, which makes the tangent of 3 pi over 2 undefined. Let's do a couple more. I'm going to go the secant of negative 120. Where is negative 120? Right down here. Got to find my x and y values associated with negative 120. That's going to be negative half and negative root 3 over 2. Next, I need to determine what I need for secant. We've already said secant's 1 over x. So I take my x value and I go 1 over that value. 1 over negative 1/2 is negative 2, which is my secant value. Tangent of 480. 480 is more than 360. How much more? I could take and subtract. This is a coterminal angle. So I'm at 120 degrees. At 120 degrees, I'm somewhere over here. Need my x and y values for 120 degrees, which puts me at a half, which is negative, and root 3 over 2. Tangent is y over x. So I take my y value of root 3 over 2, put it over my x value of a half, multiply by the reciprocal, that's root 3 over 2 times negative 2 over 1, puts me at negative root 3, and that is my tangent of 480 degrees. So we've mostly dealt with degree measures in this case. Let's move to some radian values. Tangent of negative 5 pi over 4. Got to figure out where that is. So negative 5 pi over 4 is a little more than negative 1. I'm right here. My x and y values are negative root 2 over 2 and root 2 over 2. I need my cosine, which is my x value, which is negative root 2 over 2. 23 pi over 3. Again, I'm dealing with an improper fraction. I'm going to change that to the cosecant of 7 and 2/3 pi. So I need to know where I am. We've kind of gone through this exercise before. Here's 0, 1, 2, 3, 4, 5, 6, and 7 pi. And I need to go 2/3 more from here. So I'm traveling once again in a positive direction. 1, 2, 3, 4, 5, 6, 7. And now I need to go 2/3 more. So here's 1/3, 2/3, which puts me somewhere in this fourth quadrant. And I'm at a third. So I say, what's my x and y value at thirds? I'm at a half and root 3 over 2, but the root 3 over 2 is negative since I'm in the fourth quadrant. I'm looking for a cosecant, which is 1 over my y value, So therefore, I need to take 1 over negative root 3 over 2, multiply by my reciprocal, and I have basically 2 over root 3, which is negative. Rationalize, and I get negative 2 root 3 over 3. Now, one of the things you can do to help you kind of memorize or get to know these values on the unit circle a little bit better is to notice a pattern that exists here. So if x is my cosine, notice the pattern, 3, 2, 1. My sine has a pattern of 1, 2, 3. So once again, cosine 3, 2, 1, sine 1, 2, 3. And the pattern continues all the way around. 3, 2, 1 cosine, 1, 2, 3 sine. 3, 2, 1 cosine, 1, 2, 3 sine. Might just help a little bit. Now, we're going to take a different slant on this. We're going to find the cosecant and the tangent value if I have an angle in standard position that passes through negative 4, 7 on the terminal ray of the angle. So what that states is it states I have some angle going through negative 4, negative 7 on a circle. Now, the problem is in this case I'm not on the unit circle anymore. So what I have to do is find out, well, what is the ratio of values that give me cosecant and tangent? Well, the cosecant is equal to the hypotenuse over the opposite, and tangent is equal to the opposite over the adjacent. Now, the thing we don't have in this case, if I have negative 4, 7, I know my x is negative 4 and my y is negative 7. Notice I've got a right triangle. Here's an angle, but I don't have an hypotenuse, which I'm going to need. So I know that negative 4 squared plus negative 7 squared is equal to the hypotenuse squared. I've got 16 and 49, which is my hypotenuse squared. This gets me 65 for my hypotenuse squared. Therefore, root 65 equals my hypotenuse. And once I have that hypotenuse value, notice that's going to be positive because the radius of a circle is always positive. I can find my cosecant. That's equal to my hypotenuse, which is root 65, over my opposite side. Opposite to this angle here is negative 7. And then my tangent is equal to my opposite, which is negative 7, over my adjacent, which is negative 4, or 7/4. That was a lot today. So make sure you do your Connect Ed, fill out your lesson summary. We'll talk in more depth tomorrow.